Good morning, students. Today's topic is Arrhenius concept of acids and bases. So, according to Arrhenius, what are acids? Acids are substances which dissociate to give hydrogen ions in aqueous solutions. And bases, what are bases? Bases are substances which dissociate to give hydroxyl ions in aqueous solution. Okay. Acids are substances which dissociates to give hydrogen ions, okay, to give hydrogen ions in aqueous solution. Now, some of the examples: HCl, HNO3, CH3COH. So, in their aqueous solution, all these substances give H plus ions. Okay. Now, bases are substances which dissociates to give hydroxyl ions. Okay. Hydroxyl ions in aqueous solution. Examples are NaOH, KOH, etc. Okay. Now, see, the reaction is taking place like this. HX. They dissociates to H plus and X minus. Okay. So, H's with water. What happens? H3O plus hydronium ion is obtained, that is H2O accepts one H plus ions from HX. So H3O plus X minus. Okay. These ions are present in water. So because these H plus ions are highly reactive, so bonds are formed with oxygen atom present in H2O molecule and form hydronium ion. This hydronium ion is trigonal bipyramidal shape. Okay. Now what will happen in the case of bases? MOH. They dissociate to M plus and OH minus ions are liberated. Here also hydrated ion is obtained. Okay. Now there is an important limitation in Arrhenius concept. We know ammonia is highly basic. Okay, but it does not contain any hydroxyl ion. So, basicity could not be explained here. In the case of Arrhenius concept, the basicity of ammonia could not be explained. This is an important limitation. Okay. Bronsted Lowry concept of acids and bases. So, according to Bronsted and Lowry, acids can donate hydrogen ions or they act as proton donor. Okay, and bases are capable of accepting hydrogen ion. They are act as proton acceptor. So, acids can donate hydrogen ion. Okay, acids can donate hydrogen ion or they can called as proton donor. Okay, and bases are capable of accepting hydrogen ion. Okay, accepting hydrogen ion or they are proton acceptors. Okay, proton acceptor. Now, let us take an example in the case of HCl with H2O. What happens? So, this HCl is an acid. So, it donates hydrogen ion and here H2O acts as a base. It accepts that hydrogen ion. Okay. So, form H3O plus. and Cl minus. Okay, so acid donates its H plus ion. So this will be acid base. Okay, now let us take in the case of ammonia. Ammonia is a base. Okay, it's a base reaction with H2O. So here H2O acts as acid. So H2O donates its H plus ions. Okay, so NH3 acids that H plus ion and form here acid. Okay, plus OH minus. This will be the reaction and this will be base. Okay, now NH3 is a base, so its corresponding acid will be NH4 plus. So this is the conjugate acid. This is called as conjugate acid and this is the acid and its corresponding base is OH minus. So this is the conjugate base. Okay, so acid-base reactions involve transfer of proton from acid to a base. Okay, next, amphoteric substances. What are amphoteric substances? Amphoteric. Substances which acts as acid as well as bases are called amphoteric substances. So in this case, H2O here it acts as a base and here it acts as an acid. Such substances are called as amphoteric substances. Substances which acts as acid as well as base. Okay, such substances are called as amphoteric substances. Okay, take some examples. H2O. Another example, HCO3 minus, then HSO4 minus. These are examples of amphoteric substances. Okay. Next, conjugate acid-base pairs. Conjugate acid-base pairs. Okay. So, in this case, let us take an example. HCl plus H2 gives H3O plus X minus. In this reaction, this is an acid and this acts as a base. Okay, so the base corresponds to this acid is X minus. So this is the conjugate base of acid, that acid. Now the acid corresponds to this base is this one. So this is the conjugate acid. Okay, so base formed by the loss of proton from an acid is called as conjugate base. Okay, so this is the conjugate base of this acid. Okay, base formed by the loss of proton from an acid is called the conjugate base. Okay. Now, acid formed by the gain of proton by a base. Acid formed by the gain of proton from a base is the conjugate acid of that conjugate acid of that base. Okay, this is the reaction. So here this is the pair and here this is the pair. This is the conjugate acid base pairs. Okay, now the conjugate base formed from a strong acid is a weak base. Okay, and acid and vice versa. Okay, if an acid formed from a weak base is a strong acid. Okay, so from HCl, X minus is obtained. HCl is a strong acid, so its conjugate base is a weak base. Okay. Now, in the case of H3COOH, this is an acid. The base formed is CH3COO minus. So, the conjugate base formed from a weak acid is a strong base, and vice versa. Okay.